1. Roasting. Gold exists in nature mainly in the form of pyrites. Therefore, it is necessary to remove the sulfides, hence roasting is performed. This is a 25 ml size silica crucible which is going to be used for roasting. So for roasting, we first have to weigh. Place the crucible in the weighing balance, tear it, and mix thoroughly the sample from the container and weigh 20 grams of the sample in the crucible. This huge 20 gram will take nugget effect homogeneity into consideration and will represent the whole sample. After weighing, the crucible are taken near the muffle furnace. Then we are going to place the crucible inside the muffle furnace in this fashion. Then the samples will be roasted at 700 degrees Celsius for 4 hours. Roasting can be enhanced by addition of some oxidizing agent like KNO3, and this is how the furnace looks at 700 degrees Celsius. After roasting, allow the crucible to cool, then on the next day remove the crucible from the furnace and keep in the position as you have placed.
Now this is the second step called digestion, and these are the finely roasted sample, and these are the very clean conical flasks, and with the help of brush and plastic sheet we will transfer from crucible to the our conical flask. This is the way to transfer these samples, and you can see this sticked matter will be cleaned with the help of brush.
It is mandatory to clean it properly, otherwise, who knows, your gore particle is stick on the wall of the crucible.
Now roll it and put it serially in the concerned conical flask, like this. Now you can see that this is transferred in the conical flask very nicely, and these all are transferred to the conical flask. Now the next step is to add aqua regia on this. For this we need HCl and nitric acid, 3:1 ratio, we know very well. Now we have to be very cautious about this. By wearing gloves we will add HCl to the 1 liter beaker, 600 ml. So according to the ratio we need 200 ml HNO3 for this to make 800 ml aqua regia. And at that time we have to be very careful because these are highly concentrated
And corrosive also.
So you can see that this is 800 ml aqua regia. there is a change in color. From transparent it will become orange, and then red and brown. After some time there is effervescence and bubbling. Now you can see that some bubbles are there. Now it's around ready to add in our samples. Now we will transfer 50 ml aqua regia to each conical. Now you can see the effervescence in aqua regia. Now with the help of small beaker, because it is very convenient to use, we will add 50 ml each. For routine analysis, to maintain the activity of the aqua regia, we add this in small lot to each flask at the same time. As you can see, sometimes it's more effervescence because of
carbonate samples. In those cases, one has to be very careful. So you have to have water very convenient to you nearby to tame the reaction.
Now slowly we will put all these things on the hot plate. The bottom of the flask should not be sticked with the sample or acid. It should be a homogeneous kind of solution.
Step 3. Hot digestion. In this step, we will heat the cold digested samples at 150 degrees Celsius for 2 hours or till syrupy mass is obtained. The effectiveness of the acid increases at optimum temperature of 150 degrees Celsius. While heating, we have to take care of the sample so that drying does not happen, else we have to repeat the whole process again.
Step 4. Pre-extraction step. In this step, we are going to prepare our samples for extraction. These are the hot digested samples which have been cooled to room temperature. Now these samples will be transferred into 100 ml beakers. For transferring these samples, we will use 20% HCl. 20% HCl is used to obtain maximum extraction of gold. While transferring the samples, make sure all content goes to 100 ml beaker. After transferring, make up the volume to 100 ml using 20% HCl. We will allow the solid particles to settle down by keeping these beakers overnight. This is a batch of samples where this exercise has already been done. Here you observe that the supernatant part is clear and hence we can proceed for extraction. Step 5. Extraction. This is the most crucial part of gold analysis, where gold is separated from interfering element iron. Measure 50 ml supernatant liquid with the help of measuring cylinder. Now Transfer this liquid into the separating funnel. After this, measure 10 ml of MIBK with the help of measuring cylinder and add it to the separating funnel. Here we are maintaining 5:1 aqueous to organic layer ratio for optimum extraction. Remember, take proper safety precautions while using MIBK because of its acute and chronic health effects.
Now, close the lid and shake the funnel vigorously for 2 minutes as shown. Then, place the funnel on the stand, and after some time you will see that the two layers are being separated, and you will observe that there is change in color in the organic phase as iron and gold particle has come into it. Now open the lid of the funnel, and we are now going to remove the aqueous phase as our target element is now in the organic phase only. During the removal of the aqueous phase, we should be very careful so that not even a few drops of organic layer should go along with the aqueous layer. Then washing is done with 5% HCl solution, and the same procedure for shaking will be performed, but this time for 30 seconds only.
After 30 seconds, we will observe that the color of organic phase becomes lighter and lighter, while the aqueous phase becomes colored. This is due to the leaching of iron particle into the aqueous phase by 5% HCl. We are going to repeat the washing process with 5% HCl till transparent organic layer is observed. This will ensure that only gold MIBK complex exists and iron has been totally removed from the organic phase.
Generally, transparent organic phase is obtained after 2 washing with 5% HCl solution. But sometimes it may take more number of washing.
Here comes the twist.
If you want to detect gold in ppb level, then collect this organic extract into test tube and aspirate in GTA. And for detection in ppm level, collect the organic extract into a 50 ml beaker followed by washing with 5% HCl solution and make up the volume to around 25 ml.
Now, we will be showing you the extended procedure for detection in ppm level. Place the beakers over the hot plate at a temperature of approximately 100 degrees Celsius and evaporate the solution to bring the contents in the beaker to less than 10 ml. This will bring gold into the aqueous solution.
When the content in the beaker shows less than 10 ml mark, we remove it from the hot plate and then cool and keep it for further step. Step 6. Aspiration. In this step, you will get the results of your hard work. These beakers are the cool beakers from the previous step Now we will transfer the content from the beaker to the test tube. While transferring, if required, we wash the beaker with 5% HCl solution, and we will make up the volume in the test tube to 10 ml mark. After that, we close the lid and shake it vigorously and place it in the test tube stand for aspiration.
This is the flame AS instrument. We will measure gold by aspirating the prepared solutions. But before aspiration, we will prepare standards for calibration. The standards are prepared by successive dilution from 1000 ppm stock solution as shown on the screen. As you can see, the samples are aspirated in this manner and gold is determined at 242.8 nanometer.